Hello friends, today we are going to discuss about current mirrors, simple current mirror, simple current mirror, and its sources of error, or you can say systematic mismatch. Okay, so why we need current mirror? Its purpose. What is its purpose? Now suppose you have some circuit, say you have some circuit and it needs say current, say I, 2I, say 4I, or maybe I by 2. Now with current reference you are not going to generate these currents, you will generate only one current, which is known as I reference current, and with this I reference current, this current go in current mirror, and we are going to generate all these currents. So and this circuit is current mirroring. For example, you have generated some IREF current, and you need similar IREF current for some other circuit. So what you will do, you will replicate this current IREF to another circuit, that is that circuit. Yeah. Now how this current is going to replicate by this current mirror? Why this circuit is known as current mirror? Now say this is M1, this is M2. So this is say I out. So here I out equals to I ref. But why? Because VGS1 equals to VGS2, because this is diode connection and both gates are equal. So this current IREF is given by half nu n COX W by L VGS minus VT H square. So I out equals to I ref because both VGS are equal. Now suppose you want to replicate say 2 I ref current. So what you will do, you will here size of both devices are W by L. So you want, this is IREF, and you want here 2 IREF, 2 times of IREF. So if this size is W by L, you should take, or you have to take 2 W by L size. VGS1 equals to VGS2, because now this is IO, I out equals to half nu n COX W by L, 2 W by L here, this is L. VGS is same for both, so I am taking VGS minus VTH. VGS1 equals to VGS2 equals to say VGS. So here this will be IO equals to 2 I ref. Now if you want say 4 times of I ref, 8 times of I ref, say n times of I ref, we can generalize this like this is I ref, this is n, I ref, and this is equals to I naught. This is N W by L. This is W by L. VGS for both is same. Only this is N times of WL. Size is N times of W by L of reference devices. So this is M1, this is M2. Now suppose if you want to, or if you want Iref by 2 current, what you will do? You will this is Iref, this is Iref by 2, this is say W by L, this is W by L, this is W by L. So actually this size is W by L divided by 2. So in this way you can drive Iref by 2. Now what are the sources of error in this case? Now sources of errors. So number one is lambda effect. What is lambda effect? Mismatch in VDS1 and VDS2. VDS1 not equals to VDS2. Second one is due to layout there is a say source resistance. Source resistance due to layout. Third, architectural mismatch. And all these three kinds of mismatch you can consider it as a systematic mismatch. There is another type of mismatch which is known as random mismatch. First we will see these three mismatch, then we will go to random mismatch. Okay, so now what is systematic mismatch? We will see one by one. So first one is lambda effect, or VDS1 not equals to VDS2. If we plot ID versus VDS graph, and say there is a lambda effect, so it will go like this. Here lambda not equals to 0, and for this case lambda equals to 0. If for device M1 this is I1, and for device M2 VDS is VDS2 and current is I2. So VDS1 for device 1, VDS2 for device 2. So if we draw here, this is say I1 and this is say I2, this is M2, this is M1. We want to replicate I1 to I2, M1 to M2, we want to replicate current. Now VGS is same, but VDS for both devices are different. VDS1 not equals to VDS2, therefore I1 not equals to I2, and because of this delta I equals to I1 minus I2. So this is delta I. So there is a mismatch. Thank you.